Delta star transformation. Sometimes three registers are connected in such a way that it forms a structure which looks like the capital delta. Here three registers R12, R13 and R23 are connected between points 1 and 2, 1 and 3 and 2 and 3 respectively. This type of network is called a delta network. In some situation, we need to change this type of delta network in an equivalent star network where three register R1, R2 and R3 are connected between points 1, 2, 3 and a common point S. And this type of network is called a star network since it looks like a star. Here the relation between these two sets of registers are respectively R1 equals to R12 into R13 by R12 plus R13 plus R23, that is total resistance in the delta network. Similarly, R2 equal to R12 into R23 by total resistor in the delta network, and R3 equals to R13 into R23 by total resistor in the delta network. Let us have an example. Here a circuit is given and we are told to find the equivalent resistance between point A and B. This type of network has no symmetry and this network is not a balanced Wheatstone bridge. If it was a balanced Wheatstone bridge, we may have cancelled the 6 ohm resistor, but here it is not possible because this circuit has no balanced Wheatstone bridge configuration. Now we take 3.1, 2 and 3. In between 4 ohm, 6 ohm and 8 ohm resistor are connected and this forms a delta. To find effective resistance between point A and B, we first convert the delta 1, 2, 3 of figure into its equivalent star. So 3 resistor 4 ohm, 6 ohm and 8 ohm connected between point 1, 2 and 3 forms a delta, and we will transform this delta network into an equivalent star network. Here R12, that is resistor connected between point 1 and 2 is 4 ohm, R13 that is resistor connected between point 1 and 3 is 8 ohm, and R23 that is resistor connected between point 2 and 3 is 6 ohm. So our equivalent, so in the star network the equivalent resistances will be R1 equals to, we are using the formula already given and we get R1 equals to 16 by 9 ohm. Similarly, R2 equals to 12 by 9 ohm and R3 equals to 24 by 9 ohm. So this network now becomes like this network. Here we have converted this delta network with resistor 4 ohm, 6 ohm and 8 ohm to this star network with resistor 16 by 9 ohm, 12 by 9 ohm and 24 by 9 ohm. Now here we can see that 12 by 9 ohm resistor and 8 ohm resistor, these two resistors are in series combination. Similarly 24 by 9 ohm resistor and 4 ohm resistor are in series combination. So their equivalent resistance can be easily calculated and the network now reduces to like this network. Here we have calculated the equivalent resistance of series combination of resistor 12 by 9 ohm and 8 ohm as 84 by 9 ohm and 24 by 9 ohm and 4 ohm as 60 by 9 ohm. And now these two resistor, that is 84 by 9 ohm and 60 by 9 ohm are in parallel combination. So their equivalent resistance can be easily calculated and we get it as 35 by 9 ohm. So the equivalent circuit now reduces to this type where 3 resistor of value 4 ohm, 16 by 9 ohm and 35 by 9 ohm are connected in series. So their equivalent resistance will be the sum of these 3 resistance, which is equal to 87 by 9 ohm. Now we will discuss about star to delta transformation. Sometimes it is required to convert a star network into a delta network. Here a star network is given where three registers R1, R2 and R3 are connected between point 1 to 3 and a common point S. This type of star network can be converted into a delta network where three registers R12, R13 and R23 are connected between point 1 and 2, 1 and 3 and 2 and 3 respectively. Here the relation between the two sets of registers are R12 equals to R1 plus R2 plus R1 R2 by R3, R13 equals to R1 plus R3 plus R1 R3 by R2, and R23 equals to R2 plus R3 plus R2 R3 by R1. That is, if we know the value of the register R1, R2 and R3, we can find the value of the register R12, R13 and R23 for the delta network by this relation. Here is an example of this type of conversion. Here we are told to find the equivalent resistance between point A and B in the circuit. Here we can see that a delta network has been formed by three resistors, one of value 9 ohm, one of 1 ohm and one of value 1.5 ohm between the points A, B and C, and there is also a star network between point A, B, C and point D, which has three resistors of value 6 ohm, 4 ohm and 3 ohm. To calculate the effective resistance between A and B, we first convert the star network between AD, BD and CD into equivalent delta and combined in parallel with the given delta ABC. Now the star network is like this, where three resistors of value 4 ohm, 6 ohm and 3 ohm are connected between point AD, BD and CD respectively. Now when we convert the star network into an equivalent delta network, we have to find the resistances RAB, RBC and RAC. Now these are calculated as RAB equals to RA plus RB plus RARB by RC. Therefore we calculate it to be 18 ohm, and RBC, which we calculate to be 9 ohm, and RAC, which will be 13.5 ohm. So the equivalent delta network looks like this, where three resistors of value 18 ohm, 9 ohm and 13.5 ohm are connected between points A and B, B and C and A and C respectively. So this type of circuit was given to us, and we have converted the star network between point A, B, C and D into equivalent delta network, and the circuit now becomes like this. Here we can see that the resistor 9 ohm and 18 ohm are in parallel combination. Similarly, the resistor of value 9 ohm and 1 ohm are in parallel combination, and resistor 1.5 ohm and 13.5 ohm are also in parallel combination. So there are, we can easily calculate the effective resistance of this parallel combination, and this becomes like this type of network. And when we calculate the equivalent resistance for the parallel combination for each pair of resistor, we get one as 6 ohm and one as 9 by 10 ohm and the other is 27 by 20 ohm. Now we were told to calculate the effective resistance between point A and B, so we can say that the resistor of value 27 by 20 ohm and 9 by 10 ohm are in series combination, and their equivalent resistance will be 45 by 20 ohm. So the equivalent resistance between A and B are the parallel combination of two resistors, one of value 6 ohm and other of value 45 by 20 ohm. So we can easily calculate the equivalent resistance between point A and B, which will be the equivalent resistance of parallel combination of two resistors, one of value 6 ohm and other of value 45 by 20 ohm. And we calculate this equivalent resistance as 18 by 11 ohm.